Hello everyone, myself Azdan Sheikh and today we are going to discuss turbojet engines, a look at supersonic speed. Turbojet engines are designed for high-speed aircraft and two of the most famous ones are Olympus 593, which powered Concorde and made supersonic commercial flights possible. General Electric J79, also abbreviated as JE-J79, a widely used turbojet in military jets like F-4 Phantom. Both engines revolutionized aviation in their own ways, one for breaking commercial speed barriers and the other for military dominance. But just having a powerful engine isn't enough. At supersonic speeds, managing air intake is also critical. That's why Concorde needed a specifically designed inlet system, which we will look next at. Okay, so let's dive into it. The Olympus 593, the driving force of the Concorde. The Olympus 593 was built specifically to handle long duration supersonic flight. It produces around 38,050 pounds of thrust, with including the afterburners. To calculate into Newton, it is roughly about 169 kilonewton, which provided extra power during takeoff and acceleration. It was originally derived from a bomber engine. It was modified for Concorde to operate efficiently at Mach 2.04. But running an engine at such high speeds come with challenges, primarily managing airflow. At supersonic speeds, air needs to be slowed down before entering the engine. There where the inlet systems came in. So let's discuss it more. Variable geometry inlet of Concorde. At Mach 2, the air rushing forward towards the engine is too fast for it to handle. If not controlled, it could cause the compressor stall, making the engine useless. Concorde's solution. A variable geometry of inlet that automatically adjusted to control the airflow. It worked using ramps for guided air and created shock waves to slow it down. Spill doors that release extra air to prevent excessive pressure built-up. A shockwave compression process that increased the efficiency. The system was key to ensure stable operations at supersonic speed, making Concorde's flights smooth and efficient. Why this engine inlet system work? Okay, so the Olympus 593 and its precisely designed inlet work together to keep Concorde flying at over twice the speed of sound. The inlet managed airflow, preventing the engine from stalling. The engine delivered stable thrust while handling extreme temperatures. Together, they made it possible for Concorde across the Atlantic in about 3.5 hours instead of 8 hours, which a traditional flight took. The system pushed the limits of aerospace engineering, and even today, it remains one of the most advanced commercial propulsion designs ever created. That's all from my side. Thank you for listening.
Hello everyone, my name is Apurva Davne and I am explaining about the supersonic fighter aircraft which is MiG-21. So engine and their inlet system. So explore the inner working of the MiG-21's powerful engine and understand the sophisticated air inlet system. So my first point is the propulsion system. The MiG-21 is released a single engine design. It provides the both high thrust and rapid acceleration. The air intake system is critical for feeding air to the engine. It needs to operate in varied conditions. There are the 2 points is single engine and air intakes. Single engine is the high thrust output and air intake is the critical for feeding air to the engine. So my second point is inlet design and shockwave management. Nose mounted intake. The MiG-21 has a shock cone in the nose that regulates the airflow into the engine. Second one is the variable geometry. The shock cone moves forward and backward to adjust the airflow and optimize the performance at a different speed. So their purpose is at a low speed more air is allowed into the engine. And second one is at a high speed the shock cone moves forward to create a shock wave and showing the compressing the airflow before the entering the engine. This is the essential for supersonic flight as a jet engine cannot handle supersonic airflow directly. Let's move to the next slide. So my third point is Tumanskaya R11 and R25 engines. The MiG-21 is primarily used to Tumanskaya R11 and later the R25 engines. These engines often increases the thrust. The R25 improve upon the R11 with better fuel efficiency. It provides the enhanced performance at a high altitude. The R11 engine is initial engine with high thrust and R25 engine is improve your fuel efficiency. Let's move to the next slide. My fourth point is air inlet system of the MiG-21. The inlet system is designed for high speed performance. It ensures the stable airflow. Auxiliary inlets open to provide extra air at a low speed. These inlets close during the supersonic flight. So let's move to the next slide. So my fifth point is inlet function at a different speed. At the subsonic speed, the auxiliary inlets are open. This increases the mass flow of air to the engine. At a supersonic speed, the shock cone optimizes airflow. The auxiliary inlets close to reduce the drag. So there are the two types is subsonic or supersonic. Subsonic is auxiliary inlets open and supersonic is shock cone optimized airflow. So next move to the next slide. My last point is engine and inlet interaction. The engine and inlet system are carefully matched. This ensures the efficient combustion. This provides the stable engine operation. Improper airflow can lead a engine. This can causes a loss of thrust. So overall I am explaining about engine and inlets of aircraft. Thank you.
Welcome. Today we explore the F-16 Fighting Falcon's engine and inlet system. These components are vital to its performance, making it dominant fighter jet. The F-16 Fighting Falcon relies on the powerful engine and a carefully designed air inlet presentation. We explore the engine and inlet system of this iconic fighter jet. We will cover the engine model, inlet design, and their interaction. The overview of the F-16 propulsion system. The F-16 propulsion system is critical. It's provided thrust to supersonic flight. The system includes the engine inlet and the control system. These components work together seamlessly, and it provides better thrust to weight ratio. The the Pratt and Whitney F100 engine was one of the original engine of the F-16 the General Electric F110 engine. The high thrust output and improved durability and enhanced performance of the engine. The air inlet system of the F-16. The F-16 air inlet system is a crucial. It efficiently supplies air to the engine. It is designed for the optimal performance and various speed. It minimizes turbulence. F's divertless supersonic inlet. The some F-16 variants feature the uh, DS, DSI. It reduces weight and complexity. Boundary air control. The help maintain smooth airflow into the engine. Functioning of the inlet and the different speeds. The air inlet adapts to different speed at subsonic subsonic speed. Efficient airflow to the engine and transonic transonic speed, managing the air stability. At supersonic speed, it manages shock loss and it provides the stable airflow to the engine. Engine and inlet interaction. The engine and inlet must work in harmony. The inlet provides the engine with the correct airflow. The engine's performance affects the inlet's efficiency. This interaction is critical for the stable. Advantages and challenges of the F-16 engine and inlet design. The F-16 inlet offers many advantages. They provide high performance. There are also challenges such as maintenance and complexity. Engineers are continuously improving the design. Future engine technology for the F-16, the improved fuel efficiency, increased thrust, reduced maintenance.